basically it's going to be this one, then this one, then this one. So 1, 2, 3, 4, and 5 for this one.
Yeah.
Are you going to do that or?
Yeah, I can do that.
Yes. Okay.
Behind.
All right. So you can start with this one, I think now.
Okay. Start now.
Yeah. Yeah. You can put it up.
Okay.
No, because he has to put the...
Let's see.
It will come.
As you like.
Yeah, and also viewing.
Okay then.
I think you should have it in places and...
Leave it here. Maybe doesn't disturb nobody. I think in the first row nobody's gonna be anyway. Sorry? Nobody's gonna sit here anymore.
Oh, sorry.
Navid, you were here, yes.
Even though they're terribly fast, we have to push them anyway.
Broadcast. And it will be stored forever.
It's the internet.
All right. I think we can start. I know that there was a little bit change in the schedule. Everybody thought that this thing starts at 2:30. Then everybody realized that the program has shifted for the second day to 2, not 2:30. So welcome to the second panel of the conference on network slicing. We had excellent conversation during coffee break about what network slicing is and what isn't. And I'm pretty sure that everybody has his own image, photo, understanding about network slicing. In 1 hour and a half, obviously, we will not be able to cover all of this stuff. But what we will concentrate on was basically stuff that was mentioned here and there during the 2 days of the conference, including the workshop. And one is business. And in business, the important thing is that when you sit in the table, you always know how is the money flowing. Are you the guy who's getting the money, or are you the guy who's paying the money? If that is not answered when you start doing network slicing business, you're probably in a difficult situation. Then I think there were at least 2 sessions, I think, on network slicing implementation. How do we get this thing done? And I think we were having very qualified panelists today to answer all of this. Network slicing obviously is an opportunity. That's how has it been pitched for years now, and we still believe that this is the case. And when all the dust settles, there will be opportunities out there. And there do exist use cases, even though sometimes they look a little bit artificial, and sometimes we find out that 4 out of 5 use cases that we have been talking about for so long are no longer valid, or they will never be the killer app. The panel questions you have seen already in the description of the panel. We will deal with technical and research questions. I think one of the key issues we have been seeing is dynamic resource allocation, for that matter, as well as management orchestration. We will discuss with deployment. We will talk about deployment. How is the industry moving forward with this? And a key part of this panel is, I think, the open standards and open source, how they relate together and how they move this industry forward, as well as academia. And then, of course, we will have our crystal ball time, where we try to see how this would look like in 2023. So how do we get this panel going? We need a slicer, somebody who will actually make business out of this. We need a hacker, and I was warned that hacker tends to have a negative connotation. For those that have some, let's say, some years in computer science, actually that's a little bit of an oxymoron, because we knew hackers as the good guys, like Brian Kernighan, for example, and not like this other guy that you hear about in the news. So these are the kind of hackers we're looking for in order to make network slicing happen. And of course, you cannot make more money without more brains. And just to put a cherry on top of that, we will have a tip of how this could look like at the end. We have very distinguished and exceptional, I would say, panelists today. They all have doctorates, but we will stick to first names. Antje is coming from Deutsche Telekom. Navid is coming from EURECOM. Rebecca from SICS. And Dirk from InterDigital. I think most of you know them, and if not, you will get to know them better during this session. The rules of the game. How do we put this together? There will be an introductory talk by each of the panelists, about 15 minutes. I will do the official timekeeping. During this time, please think and write down questions. It will be extremely useful at the discussion session because we want to make this interactive. There will be time also for clarification questions right after a panelist has concluded his presentation or her presentation. And then we think that probably, given that we started a little bit late, we will have something between 15 and 20 minutes for questions. I know that I will get questions. I have prepared some. Please don't let me use them. It will be much more fun if you ask the questions. And with that, Antje, I think you go ahead. And thank you.
Thank you, Kostas. Thank you very much. So we do have a clicker, right? Fantastic. Yeah, actually, nice to see you again. I don't know, maybe some of you have met me before in Oulu. And I'm actually surprised they still invited me to talk for you because of the last time I spoke. And I promise to be very, very friendly and not at all aggressive, but we hope to entertain you a little bit today about network slicing. I'm here today in a double role, so I'm working for Deutsche Telekom, that's what Kostas said, and which is absolutely right. But I'm also representing today a thing that it's called Slicing Association. You might have heard about it. We just published that we start our work, so it's not too much done yet, but I will come to the idea what it is a little bit, and then also try to explain why we think it's so important. What I find interesting is when we look back a year ago and when we look at what we had and standards and so on, and also when you look at the projects that was running in the first round here in 5GPP, it was very radio focused, which is fine, which is absolutely fine. That was the first wave. And I think now we are more at the point to look at other topics, and that one of these other topics is obviously slicing. I heard from yesterday, I wasn't here, sorry for that, but I heard that basically Bosch brought it to the point that everything is about manufacturing, right? And everything else you can skip. So good. Then we look at manufacturing. Let's assume that is correct. Even what would such a statement mean for network slicing? That would be interesting, right? I mean, if I just say manufacturing, that doesn't mean clearly that we know exactly what the requirements are. And this is something we actually have to question ourselves, whether we understood industry requirements. I think it's already a great sign that, like Andreas Müller from Bosch is here and presenting in our industry conference, and that he has actually a very strong opinion about our technology. I think this is the only way we get there to understand. So if I personally have a different opinion about what is slicing good for than he does. I think it's a little bit more than manufacturing. But I think it's, in general, important to understand what does the industry and the consumer require from us, and how do we feed that, and network slicing is one of the crucial points. And that is why we're all working on this. This is why you have so many sessions around it. And coming from there to say, okay, we have actually, these pictures are probably known to you. It's still this pictures coming from NGMN, the white paper we had in 2015. Do we have the same knowledge than we had in 2015? I don't think so. I think we made progress. We made progress, but it was sometimes a little painful. Yeah, everybody was talking about 1 millisecond. I haven't met nobody yet that really said, okay, we need the 1 millisecond for that use case. What we probably found out is it's more important to have a stable latency than 1 millisecond. And that is also something we do through our work. We understand better what is actually needed and not only what we think somebody needs from us. And I think that's why this left corner, the diversity of the use case, is still important to understand and to know about what it means for the different industries. And I think the rest is absolutely clear for you, but I would like to stay on the left-hand side, because that would lead to the implications for our networks and what network slicing can do at the end. So, I just mentioned it, there is a slicing association. What does that do is basically we invited other verticals to discuss with us what is actually their need. And not only discuss, the intention is also to try out things. Don't we have that already? Of course. We have a lot of plenaries, we have a lot of discussion rounds and so on. We sensed a little bit hesitance from some, let's say, companies, whether it's energy or whatever, to join clubs like the GSMA. Because they think, okay, this is the telecommunication mafia. They know exactly what they want to do. They don't listen anyway, so I don't want to participate there. A few companies. But on the other hand, they are interested to shape slicing. So we have invited them. So one of our main ones was, for instance, General Electrics. Yeah, they were part of the group, and they contributed a lot. And we see this group a little bit on this upper layer, that you say, okay, there's a vertical industry organizations. They think about 5G. There are more. Yeah, it's like 5G AA. It's different organizations. And then you have those that is more the telecom industry organizations, like GSMA and GMN, and so that could actually translate those requirements into something reasonable for us, right, to put into standardization at the end, to have an alignment in our industry, how we do certain things. So this is the generic idea. We have designed a mission. Yeah, we have what do we want to do? We want to invite. We do believe that slicing is something very fundamental. Coming back to the Bosch example, when you look at manufacturing, I am absolutely sure that there's no way we can deal with that with one slice. Yeah? I'm not so sure yet how many we need, but if you look at use cases, they are maybe rather simple for tracking. They would need different things than steering robots. Already to set up, from our perspective as Deutsche Telekom, set up a network for an industry park or a campus would already require 2 slices. That is very simplified. That is not really slices with different features. That is one private network, and this is a public layer on top. We do believe that both is needed to feed the requirement. Example, when I'm KUKA and I rent out my robots to another industry player, and I just want to do maintenance on that, nothing else. I don't want to know any details. I just want to know whether my machine runs or not. I would need a public layer because the distance is too far. Probably the industry, so the company that owns the campus, needs some more. They want to be secure about their data, so they better leave the data on campus. Yeah, they don't want this is sent through the whole internet and the whole world. So that's already, from our perspective, something which you can call slicing, that you have a public and a private layer. Additionally, on the premises, you have different requirements, and I'm pretty sure we need to establish slicing on a later stage. This is something we learned by discussing with those type of industries. Yeah. And then we would like to do that. We would like to go for trials. For instance, China Power Grid is one of our partners. They're going to trial locally with Huawei and China Mobile. They're going to try around energy grid. But we as a partner, we can participate and learn from their trials. That is the general idea, to invite those providers. This is actually at the moment the participants from the Slicing Association. This is the generic idea. What you can see here, this is one initiative where Deutsche Telekom is part of, that we are trying. This is an example on different angles to discuss slicing on different levels. We also engaged, of course, in the standardization discussion, and for us it's really, really an important feature. And that's what I would like to share with you, that this is a really important feature. There's other things my colleagues will talk about that goes more into the direction, of course, how we do this, how is the best way. This is more why we do that. And we do believe this is a unique opportunity that we only have in 5G to get this right at the moment. We also have to prove as an industry, also as an operator, that we're able to do this the right way. Because so far, we are not really offering industry scale solution to our business partners. Yeah, we started with M2M, but it's a rocky road for the time being. But I hope that those kind of things help to do that. That's basically it. Thank you very much. And I will go over to Navid.
Hold on. Clarification. Do we have any clarification questions from the audience, first of all?
Clarification.
So I have a clarification question.
Yes.
So you talked about the association.
Yeah.
What's the outcome? You're going to have white papers, so you have like a set deadline, the timelines to do that. You have open events. How do the average researcher out there, if I don't work for any of these organizations, how do I get to know more about this?
We have published, very good question, sorry. We have published one very generic white paper from these industry sectors. We have published that for the Mobile World Congress, and we are working on the details at the moment, and we will publish step by step also the outcomes of trials. Yeah, okay. So that's the generic idea.
Somehow this is trial driven, let's say.
Trial and also, let's say, intellectual property driven. So the knowledge that we would receive from our verticals that is involved, we would also publish.
Okay.
Yeah.
All right. Thank you very much.
Thank you.
And with that, let me see if I can do this. Yes. All right. Navid, you're next.
Thanks. So, good afternoon. I'm going to touch a very sensible topic related to open source and standard when it comes to network slicing. Also, give a very brief overview of the 3GPP perspective in terms of network slicing. Yes, so introduction, I think this is a common understanding of all of us where the network slicing tries to turn the physical infrastructure, for instance, RAN infrastructure, core infrastructure, into multiple logical networks, one per service. This underlying definition has two dimensions. One is that the network is not a one-size-fits-all, and also there is no dedicated network for each service. So it means really you have the common infrastructure on the top of which you can build multiple logical network. And you see actually this image from Ericsson white paper that kind of captures this idea. Yes. In terms of progress, also this EuCNC demos, also other venues, we see that different aspects of network slicing have been already studied, analyzed, prototyped, both in open source community, industrial platforms, and also commercial platforms. So this actually boils down to, in current 4G, into two simple changes in the way the network is provided to the users or service provider. One is through the provision of some local services enabled by the MEC platform, which under standardization by ETSI. And another one is related to having a dedicated core network. So these also have different flavors, whether the control part is shared or dedicated, and so forth. The natural next step 3GPP is looking to is having a service-oriented core network and service-oriented radio access network. And to a large extent, 3GPP today progressed a lot in terms of service-oriented core network. They actually defined two different architectures, and eventually they moved to the second architecture, which was this service-oriented core network. And their agenda is quite aggressive, and a lot of specification already released to specify this service-oriented core network. I think this is a quite common picture we are familiar with, where we see how the future 5G network will look like. So you see the RAN network is disaggregated into multiple entities, so you don't have any more a monolithic base station as we had in the 4G. You have a kind of disaggregated radio access network, a little bit like 3G, like you had RNC and base station here. The terminology is CU, DU. So DU is technology specific, CU is more like an aggregator, could be running in a cloud environment. And then you have a user plane function that basically gets the user data back to the network. And they also, 3GPP defined these three functions where they are really slicing specific. So this is the enablers for core network to put in place the slicing in the core network. So more precisely, this is a table from 3GPP from one of the meetings in the RAN. And this base clearly shows the comparison between 3G, 4G, and 5G. And here I highlighted in green what is really specific to network slicing. So 3GPP already from scratch considers network slicing to be natively supported in 5G. One very interesting feature is quality of service. You see flow-based. So in 4G and 3G and also 2G, we had this concept of bearer, which is kind of a tunnel under the control of the operator, and that made the slicing very difficult because you need to have different level of slicing in the RAN network, whereas in the other segment you have always flow level, like SDN switches, you do flow level slicing. So with this addition, which is optional, there is a layer that is optional for 5G new radio, this flow level slicing could be enabled. And it could open up more end-to-end slicing and more, let's say, harmonious across different segments of the network, transport, RAN, and core. And of course, inbuilt cloud support. This is one example I like because it shows one device like a car could potentially have 3 slices. This boils down to having this logical network in one base station. So you have one runtime environment on the base station through which you have some logical network, which is more than just having quality of service. You have isolation and control. And you see on the core network, some functions are dedicated, some functions are shared. For instance, AMF is shared in this example, whereas SMF is, for instance, dedicated. Now I go to the core of the topic. It was more like an introductory. So I have 2 questions, 2 answers. And I think this already set the scenes of what I'm going to explain next. So can open source without a standard? Of course. You can do open source without a standard, and there is a lot of examples in the nature. And the inverse question is also true. You could do a standard without open source. So this was typically the 3GPP approach in the past. And now the question is there any interplane specifically for the mobile network to somehow exploit this interaction? And as a matter of fact, ETSI organized a workshop in 2015, or maybe 16, I think 2016, that actually invited many players to discuss exactly this topic. So the message here that they are complementary. So I try to reflect this through this infinite loop where you want to retain a long-term stability and interoperability, and that's why standards are very helpful. You need them. But at the same time, you want a fast innovation. The pace at which 3GPP is producing specs in 5G is much faster than 4G. So the things are progressing faster and faster. And this fast innovation and development phase could be done by open source initiatives. And what has to be realized here is that open source played a big role outside of the 3GPP network. When it comes to 3GPP network, it is quite closed and very much protected by the IPR. And we had a presentation in NGMN in 2015. We just presenting this idea of open source for 5G, not as a whole solution, of course, as a piece of open source. And the first question people asked us, how do you manage the IPR? So that is a big question. But at the same time, we also need an open source to lower the entry barrier because of the cost reduction and also reuse of the function across different type of deployment. And also having a common R&D framework through which different players, academy, industry, could validate the solution proposed by 3GPP is also essential here. So when you see a given approach, you could actually have the possibility to test it. So this means that maybe there is a reference design. It's not a product. There is a reference design. Some of the proposed features could be examined and analyzed there. So there was in that ETSI workshop in 2016, there was one question about the license. If the IPR is very sophisticated topic to manage, how we could marry open source with the standard and with the IPR. And there was actually one of the Ericsson's lawyer there, and he actually brought up the topic of a FRAN type license for this open source. And basically, this is not widely accepted, but many players already accepted this type of license. In Open Air Interface Alliance, this OSA license is one example of a FRAN type license through which you could release a code as an open source. Those that they have patent, they could preserve the IPR even though they implement themselves the feature they have patent on. So this is debatable, but this is one safe way to go forward. And that, of course, naturally leaves the room for the commercial use, but also for the academic research and prototyping use. Another dimension is that, that also ETSI is looking, we are also discussing with them, is to have an open source community actually being present in the 3GPP discussions, to actually being able to contribute one way or another to the standard. And the return for the standard is that they have this common reference platform, reference implementation, feasibility and validation of the solution proposed by 3GPP, and potentially reproducibility of what has been done by the other third-party partners. So towards the RAN white box, there are 3 areas big players are looking. Like specifying API and interface seems to be very important. Exploring open source network functions. As I said, not a complete solution. Piece of open source could be part of a product, part of the solution, depending on the market, emerging countries, developed countries, that could be different. Leveraging commodity hardware is very important to also lower the cost. And also, if you have a dedicated hardware, then virtualization becomes difficult. So you also need to enable virtualization and also run intelligence. So towards this RAN white box, there is one operator-led alliance that recently created in February 2018, which is a combination of XRAN and CRAN. CRAN more in Asia, but led by China Mobile. XRAN more in US. So this ORAN is actually trying to cover that. There is more smaller consortium-led alliance. Example is like Open Air Interface. They try to have a certain implementation, certain features, and they are also in touch with ETSI to see if there is any opportunity to exploit towards this direction. So what is ORAN Spec is that it's a combination of XRAN and CRAN. You see Deutsche Telekom is also part of this ORAN. AT&T, China Mobile, and this is a carrier-led consortium. The objective is to create a more open radio access network. So really focus is on the radio access network and the reference design. And as previously mentioned, the objective is to have this virtualized network element with open standardized interface, and also real-time analytics with machine learning, which will use those interfaces to enable such features. Example of open air interface spec is that is following just 3GPP specification. It's a consortium-led, so there is a double consortium here, where you have a combination of the industrial members and academic members. So here I put the industrial members like Orange, Nokia, TCL, Fujitsu, Samsung, InterDigital. And here the objective is to have a reference implementation and development kit for common R&D prototyping. So the code base is open source across the RAN and the core network, UE, eNode B. Open API, so there is API open, so there is an example of how this API could be opened. It doesn't mean this will be standardized, but at least there is one example people could have a look and take the lesson learned and build something better. There is also, for the front haul, there is an implementation of Ethernet-based front haul that also aligns the lines of the NGFI. And it's a fully software solution, either Intel-based or ARM-based. So this also opens the market for more ARM-based servers rather than just Intel-based server. and user and developer communities, which it's very essential and to support the development. So this is an example of all the tool chains put together, of course, supported heavily by the European Commission to perform this big development on the radio access network, on the core network, building domain-specific controllers for the RAN, for the core network, and having some tools that people could use towards this direction. There is another very complex ecosystem led by data center providers like Facebook and Google that they are entering to the telco space. There is two important projects, OpenCellular and TIP, which tries to provide, you see the example of OpenCellular on the right-hand side, which is a low-cost equipment for rural areas. And they considering an open source core network to support this OpenCellular base station. And this basically changed to a certain extent the value chain of the telecom industry, at least at the beginning for the rural area, but it might have some consequences for big vendors at some point, and they are federating open source developers, which is not happening for the big vendors. It's happening for this space, the companies like Facebook and Google, but for big vendors, this is not happening. And one of the personal fear I have, which is really personal, is that if what the things happened with the Nokia phones, where they were kind of bypassed by Android ecosystem, that we were all maybe to a certain extent sad that Nokia did not manage to make their phones viable after the release of Android. And I think here there might be similar danger where open source is exploited by these companies, and it may be dangerous for the big vendors to not be ready for such a 1% scenario. So conclusion is we see the fusion of computing, information, and cellular technology. This is completely inevitable, and I think we see a lot of papers, articles, and discussions towards this. So beforehand, we only had communication. Now there is computing for communication, information processing for the communication that are playing very, very important role. And this is said by the NGMN and by many people. 5G is not radio, new radio and vertical, but also evolution of general purpose computing for wireless networks. So it means that you really bring GPP for mobile networking, and I think this is quite important. And we see the emergence of more and more software technology, NFV, ST, and MEC, to jointly work with radio signal processing. So also, when I say MEC, there is also idea of caching. A lot of researchers, even the vendors are exploring. So that basically conclude my talk. And I will be happy to answer one or two questions, but maybe we leave the rest for the discussion. Right, Kostas? Yeah. Good.
Thank you very much for giving me the time.
Yeah.
So clarification questions for Navid. I think he covered quite a lot of aspects here, and we will get back to that very soon. Sure. One of these things is this risk scenario, this 1% scenario. I think this is quite interesting, but that's not clarification. I think that's more discussion. So Navid very nicely, more or less, leads us into Rebecca's talk. And I think while I'm doing the magic here, you're going to walk around, or?
Yeah, I'm going to walk around.
All right. So, okay.
Is it on?
No.
So where's the control?
Yes. You're on. Mm-hmm. Good.
Thank you. All right. So, hello. Thank you very much. Oh. I see some familiar faces here. This is very nice to see you. I've been working in forward, sail, unify, and coherent. So much of what I will talk about is, some stuff of what I will talk about is something that some of you will recognize. So, status is now this, that there has been up to now, and is continuing, by the way, lots of focus on building the mechanisms and the APIs and all the sophisticated advanced methods for enabling RAN slicing and the necessary control frameworks to actually be close to having something along the lines of RAN slicing. Now, what we need to do now, what the next step would actually be, is would not be only to look at the necessary mechanisms and methods, but also how we can make those mechanisms work in a self-operating way with high autonomy. So the next step is to look at triggers and how we can use triggers and design triggers in such a way that we can achieve high granular RAN slicing in a dynamic way. And in my view, the design of such triggers would typically be along the lines of being scalable, definitely universal in terms of being practically applicable to different heterogeneous networks and technologies, and capable of quantifying uncertainty. Now, behind every such trigger, there is data, and it actually matters how we build and design new data sources and models to finally develop triggers that we can act upon. And I would like to call them observability points. I think this is a very good term. We use it in FP7 Unify. And typically for the observability point is that it's capable of representing the network state along with its variability. It is typically operating in a very distributed or at least decentralized process in order to support long-term and short-term control loops. And because it's operating in a very local fashion, it also has to be implemented in a computationally lightweight manner. So that's an observability point. And what we gain by deploying local observability points is that we offload the monitoring overhead to the network and the processes to the network, instead of doing everything in a centralized manner. Centralized in the sense of having a dedicated monitoring station that will just crunch all the raw data. Because when we do it that way, we immediately limit the granularity to which we can actually observe the network, and that's detrimental if we want to the cause of building high granular dynamic RAN slicing approaches. So this is the reason. So ideally, the development and design of such observability points and data models operating locally would be that they are generically designed in such a way that they can be used to aid short-term control loops locally in the network, or be combined into more sophisticated composite models that are useful and applicable for making more sophisticated analytics for long-term control loops and management frameworks. Anyway, so the nice part with this is that now we finally have the means to actually implement and deploy such observability points, because we are now in the era of programmable infrastructures that are sufficiently open to allow us to actually do this. So now we can actually start deploying observability points basically all over the network. And instead of worrying about scalability and overhead in shunting large amounts of raw data to dedicated monitoring central source stations, we can rather look at how we can disseminate and exchange estimates instead, or simpler models that can then be used for different aggregation purposes higher up in the management layer, and then further used for example, working out new control policies that are adaptive to what is actually happening in the network. Right. So just to give an example here of the difference between using a local observability point and monitoring links and network performance in a more traditional way, we can look at this following example. So this is a real link, 1 gigabit from an ISP. And normally, we would look at this by the use of 5-minute averages, more or less. And from this perspective, we see that for being a 1 gigabit link, everything actually looks very good. It actually looks underutilized. So there are really no reasons here to suspect that anything is wrong in this picture. And I used to work as a network operations center technician almost 20 years ago, and if I would have seen this, I would just have leaned back in my chair and think that everything is good. There is nothing I need to do. Now, 20 years later, and a little bit wiser, I would approach this with a little bit more skepticism. So what I would do is that I would deploy, let's say, an observability point that is capable of reflecting the risk of overload on this link. And I would implement it and the necessary counters on the ingress of the server to which the link is plugged in. And then I would measure much more than just in 5-minute averages. I would measure many times per second. And then we would see this. A completely different picture of how the performance actually is on this link. So what we see here is a persistent syndrome of microcongestion. And this isn't very good at all. We weren't able to capture this if we would have had a better trigger like this one, being able to capture this type of link overload. We could have caught it and we could have mitigated it. There was no way that we could do this with a more traditional way of measuring using averages. So what to learn from this is, first of all, if we want to increase granularity and observability, we need to do it by deploying local observability points. There is no way that we can do it in a centralized way. This is just common sense. So if we move over to a radio access network scenario instead, we could apply basically the same way of observing and controlling the network, but make observability points that are more suitable for a radio access network scenario. So what we typically would do here is to, instead of looking at the regular signal strength or any other quality indicator and make decisions straight off the raw data, we would rather look at the throughput or the expected throughput. And the reason why we want to do this is because if we create triggers onto the raw data, we will immediately cause a lot of excessive control signaling, and that's basically waste of bandwidth. So instead, it's much better to look at how we actually want the network to perform. We definitely need to look at the expected throughput or the expected delay in the network, which will help us understand the capability of the network to actually delivering according to probabilistic service level agreements or service level objectives. So basically what we get with this more probabilistic way of seeing the world is that we get it inherently a way to estimate and express service level agreements, meaning in terms of I could, as a user, express, for example, that I want to have a service that is provided by 12 megabits per second for 90% of the session duration, for example. And that means that I can accept that there is an underperformance in 10% of the cases, but that's okay if I'm running such a service or using such a service. One can also look at this as an alternative or a higher level expression of the network state in terms of probabilities, where you can have a management framework or a controller assess the ability of the network in different parts, the bigger picture, how its ability to perform along the lines of providing X megabit per second at a certain probabilistic guarantee. Now, one other thing that this also gives us is the ability to handle variability in the network and quantify uncertainty. Because with this type of trigger, probabilistic trigger, we get the ability to trigger updates of the RON slices and the allocated resources only when we actually have evidence that it is the right thing to do. So this is the difference. And this is what we can achieve when we model the performance probabilistically. Now, what is nice now is that we have programmable radio access networks, more or less, or it's in the pipe, which means that we can start deploying observability points throughout the network. And if we follow, for example, the architecture and the concepts of Horizon 2020 coherent, then we would typically have observability points that would estimate the local attainable throughput, and it would be used by a coordinating central controller that would assess which one out of these space cells would get the honor to serve the UE. So this is just an example. Now, the grand challenges, as I see it, is that if we're going to make high granular dynamic slicing to actually work, we need to look at generic and universal triggers that are applicable to different heterogeneous radio technologies. And this is, to some degree, quite a bit of a mess, because RSSI, for example, and how you calculate it can differ very much from different vendors. So this is the main challenge, to find the generic ways of representing the network state in such a way that you can create triggers to initiate controller actions over different heterogeneous technologies. Now, once we have that, we can start specifying relevant SLOs that are user or service specific, and we can start developing proactive adaptive control loops that are capable of acting to such models. Now, there is a lot of gains, of course, with RON slicing, like we can get better resource utilization and so on, and serve more clients. That's quite obvious. I think the most interesting opportunity here is that this is an incentive to start working on developing distributed systems that are capable of learning, because this we simply don't have. This is a possibility to develop network intelligence beyond just deep packet inspection. And this is also an opportunity to develop machine learning and AI that are capable of operating at very short timescales and in a dynamic distributed environment in order to aid short-term and long-term control loops, because this doesn't exist yet. But it's a necessary thing if we want to automate different control loops at a larger scale. So, some final thoughts. So one could think of this in the following way. So monitoring and the mysteries of monitoring and new methods and advancements, it's been going on for decades, and still we haven't really solved the issue. And many things, many concepts that I just mentioned have been addressed in different projects, but still we don't have a solution. And one aspect and one factor to this is, what I think is that now we finally have open programmable networks and commodity hardware that allows us to observe the network at a much higher granularity than we have been able to do before. And this means that we will be able to make better measurements and make better conclusions and get better insights on how we should implement monitoring and high-level controller decisions and even AI-driven control loops. Another thing that also plays an important role is that we have now more advancements in machine learning, which enables us to look at data at much larger scale. This will also play an important role in terms of getting insights and understanding how different aspects and performances of the network correlates with the actual performance and the parameters. Finally, we also have open source communities now developing and evolving, and I see that the industry is now working more closer and closer with the open source community, and this will also advance the development towards high granular dynamic round slicing. So that was everything I had to say.
Thank you very much, Rebecca. Clarification questions that have nothing to do with the human aspect of slicing? Good. Then I think now that we have seen why we would slice it, how we could hack it, and how we could make it smart, it's time for the tip. So Dirk, please, as somebody has taken over remote control of this station, look, man, no hands. 5, 1 up, there. See, we're already faster, smarter. There you go. It's all yours.
Human-centric indeed. Good. So when I saw the slides yesterday, the introductory slides, I was struggling a little bit with the tip characterization. But then I thought, actually, it really isn't that wrong, compared to what I'm going to talk about. Tip is associated to a transaction. You usually do that when you go to a restaurant and leave money, at least in a number of countries you do, not in every country. And I'm going to talk about money left on the table. So that fits. It's related to a transaction. Well, I do ask a question about how does it relate to the person actually performing the actual transaction. It isn't necessarily the case. So it would be quite interesting for you to think about, and I will ask certainly the question, maybe somebody else gets the tip, right? That's certainly unusual and is different from the tip as we know it, but it might well be the case. And it isn't quite clear. Well, in a lot of countries, the tip is by conventionally set 20% in the US, 12% in the UK, almost nothing in Finland. It is usually, I'm not entirely sure what the tip amount will be. Maybe the interesting thing will be that the tip is larger than the transaction. That would be fun, right? So I actually do think that the tip analogy really fitted. And what I'm trying to ask as a question, apart from preserving the status quo or opening new opportunities, comes out of a dialogue that we are having with parties that are really feeling with vertical industries, but also with user communities. And we haven't really heard about users. We always believe that users are vertical industries in the discussions in 5G. But there are communities I talk to, they don't feel that at all. Right? They don't feel that vertical industries are really users, and they don't feel that they are vertical industries as a user community. And some of the vocabulary that I will use are actually borrowed/stolen. No, I borrowed it because I actually asked for permission from the dialogue with one of these user communities, and that's the regional authority in England. So this is the 5G PPP vision on vertical services over 5G. The attribution is down there. I borrowed the slide, the image, that's figure 3 in the white paper, in case you want to look it up. Slices, this is the beautiful picture, and slices, slices, and slices. Automotive, factory of the future, that's apparently the only one that counts, as we heard, or not. And all you do from a resource perspective is you create resource silos, right? So I'm drawing this one over, really very bluntly. You might not have one per vertical industries, you might have a number of them, the numbers might be different per vertical industries, but that's kind of the view that I see when I look at this picture, right? And essentially what we are talking about in slicing, to a large extent, in many of the instances that I have seen, demonstrated, and even argued and discussed, we're essentially isolating and essentially wasting resources. Resource isolation might be useful for security. It might be required for regulatory purposes. I might not want that somebody is transmitting on the spectrum in my industrial environment. But often it is a mean to achieve an exclusive supply over an often aggregated demand over an even longer time frame. It is waste. In most of the cases, it is waste. Cutting out certain bandwidth for EMBB is waste. It has limited scalability, because how often can you do that? A question that's very often asked, how big are these numbers? How far do you do n plus m plus k? Depending on who you talk to, I hear millions, I hear tens. I think the NGMN white paper initially talked about tens. There are a couple of blueprints there. I heard a presentation, and I had a similar presentation that talked about a slice per application. We will talk about billions then, right? So nobody really quite knows, but I do believe it will have limited scalability. The overhead of slicing is very, very significant, and therefore you can't really do it too often. So that has a little bit of a problem, which is why it is in red. But most importantly, and this is the dialogue that I have with user communities, does slicing really provide a better user experience? And for these user communities, they're not vertical industries. Again, don't think car manufacturers. These are either individual people or user communities being represented by, for instance, authorities, regional authorities, development agencies, that are using a term what they call user journeys. And I drew this horizontally compared to the slicing. As a user or a community, I care about journeys throughout my daily activities, and most of these are across silos. Yes, at any moment in time, I might use my car, but I don't do it as an end, I do it as a means to something bigger. And that's what these communities capture as a journey. I do things to get to work, I might watch a movie in between because I'm bored, and I start traversing, in case you don't remember what this slice was underneath. My user at the moment is watching a movie while he's driving. That was automotive on the right-hand side and it's EMBB on the left-hand side, right? And so inadvertently, I actually cross silos and I cross them fluidly. And so the question is, who manages these journeys? Application developers? Vertical industries? BMW might sell me an entertainment service in their car, but then again, I'm only locked into that one experience, right? Or are these the players that we are not seeing at these conferences? The famous OTTs. The OTTs who have the opportunity to become deeply embedded in the infrastructure by simply hooking into those slices and delivering the experience end users really want. Right. Another example of better user experiences, and we had this discussion in an automotive workshop the other day. I'm turning into a different road away from my digital highway, and the car stops. And there was a debate whether or not it's actually worse that your car stops or your movie stops that you're watching in the car. I'm not entirely sure what's worse, depending on the street. Right. So as a user, again, I care about journeys throughout my daily activities that cross administrative as well as country boundaries. I know that the European Commission is very interested in actually having not only automotive driving, but actually being able to drive from, probably not anymore England after 2019, but certainly from Germany to France, and the car doesn't stop. Not a particularly trivial problem, and the industry has answers to that for that particular use case, but generally I think the gist is you do want to cross things, and as a user I don't particularly care. I care about the experience. Right? And again, who is responsible for service disruption along the journeys? The vertical industries. Can I go back to BMW and say the car stopped because I took the wrong turn? Operators. And I do believe there's money left on the table, so we're getting closer to the tip. There's money left on the table to provide experience to users that the users care about, provided through vertical industries by the means of slicing. So the takeaway is really, firstly, on the technical side, static resource slicing, therefore isolation, is one mean to a larger end. And that is the sort of, the support for improved customer journeys. That has to be the end goal, to really add value to individual user journeys and to community journeys. We have limitations, I believe, in scale, and waste because of the accurate demand and supply that's being applied when dimensioning the slice. And even though breathing slices started to appear in technologies, most of the reservations and most of the use cases I heard about are very, very static. Right. At the moment, the user journeys do not change compared much to pre-5G. I still hit silos. Yes, they are sliced and they're much better managed and all of that, but as an end user, and this is the statement we are hearing from user communities, it doesn't actually change. I still have to do separate contracts, I still have to talk to different vertical industries. How did 5G really change my life? I'm still actually have to do all this kind of stuff. All I want to do is I want to traverse all these different worlds, and somebody's taking care of it. And so we're getting back to the money left on the table aspect. So moving, I believe that what helps us here is to move from management of slices to runtime control of resources, because it allows you to do things. One, runtime control can take care of changing conditions. You go into a different route. And secondly, it removes the waste issue. Right. So how would we do this? And I drew a picture that we used in an unsuccessful EU proposal several years ago, but I still believe that picture is really valid, and you see similar pictures elsewhere. We do have an orchestrator on top, but this orchestrator is not at the network level. And even though I'm a network person, when it comes to orchestration, I don't particularly care about this. It is at the service provider level. It orchestrates journey-based experiences. It's not just vertical silos, it's inherently multi-X. It is multi-domain, multi-operator, multi-technologies. Whatever the end user does, that's the service I want. And if it happens to be that I'm going into a site, a street where there is currently no connectivity by the operator, make it work. And make it work might dynamically mean there might be a community network available. Utilize that. So this picture actually came out of a set of use cases that saw the highly dynamic addition and removal of resources as part of the scenarios. So if your service didn't have an online contract, a current contract with that provider in that site street, you will add this on demand instantaneously or almost near instantaneously. Because I'm standing there, right? So you do want to have it instantaneously. You don't want to sit there for 5 minutes while the system is negotiating the addition of the connectivity. It is built for high dynamics. Again, it has to happen really. It supports for scale in, scale out, dynamic addition, removal. It moves from dynamic load to dynamic presence, and therefore it tackles very different problems. It has to do with topology discovery, topology additions, topology removals, reconfiguration, and all of that is very different from the static management of things that I actually know. Look at an oddity that we all know. We are building 5G on a service-defined network technology that utilizes a fully routed network in order to be managed. That's an oddity. In order to actually talk to the SDN switch, I have to do a TCP connection. And every network we are setting up today, which is sliced, has a management network that is fully routed, which is absolutely ridiculous, right? And this is something that you can't maintain if you actually start pulling out and adding switches and resources to the actual infrastructure, right? So we are really in this static thinking, which really is holding us back, I believe. And underneath we have resource pools. Well, I don't care. They might be sliced. They might be made native. They could be virtualized up to no end. They are just resources. But it's the bit on top that we really have to develop. So what are the opportunities here? Well, firstly, I believe that minimizing slicing to those cases where resource isolation is absolutely and utterly required is the first step. If you really want to run a movie, I run perfectly movies today. Does it really have to be EMBB and slicing something away? Possibly, if there's a good use case, but it is waste. Decrease the TCO by otherwise isolated waste of resources and move towards a dynamic, possibly auction-based market. We have perfectly working auctions today in the internet. Every time you open an ad-based web page, there's an online auction ongoing that you have no idea about. It's all happening in the background. And your actual desktop space is sold at real time. And I believe that's the model where we have to move to at the resource level as well. You move into a side street, there are 5 competing connectivity providers, and you will negotiate the price at runtime and connect to one. And again, it has to happen instantaneously because I'm standing there with my car, which just stopped. So it has to happen really fast. One thing was a pet child of mine a couple of years ago. I published a paper around pricing or paying the truck driver. The internet is really suffering from a really weird oddity, and that is that we got used to pay the truck driver. If I go into the supermarket, I pay for the goods. I never pay the truck driver. In the internet, we do. We do pay for our Spotify or Netflix, but we always pay for internet connectivity. And the oddity of pricing in the internet is really something I would like to, generally in 5G, I'd like to overcome and move to new pricing models that allow us to really pay somebody for an entire journey for a product that could be time differentiated, it could be product differentiated, but it's not individual, it's not singling out this bit that we call connectivity, right? And you look at the example where we finally got, after many years, where you can buy an actual train ticket that goes from one European country to the other one. Now, it can't be that I buy individual tickets along the way, as it used to be, and in some countries still is, right? Differentiated pricing beyond QoS, that's really where I would like to go with this. And again, dynamic control and auction-based thinking is the foundation for that. And that possibly creates a new set of players. So that goes back to the question, is the tip really for the restaurant owner, or might it be for somebody else? And I'm repeating again the player, and we call this in value chains that we started drawing and presenting even last year at the NGI forum. I presented a value chain of the future, or the next generation internet, as we call it nowadays. And there was a name there that doesn't really quite exist yet, and that's called the experience provider. And to me, this is the new OTT, and we don't see them in this room. Right? It's very telecom-oriented, but the ones who actually sell the service experience are really the interesting ones. The first two, I believe, address the waste issue, which allows you to free up resources and therefore reduce the TCO. And the second one really addresses the issue on money being left on the table, and it's free for somebody to grab. Thank you very much.
Excellent, right on time. Thank you very much, Dirk. And that concludes the panel introductions. And I guess now we go to questions from you guys. Let me just pull this up. So I think we kind of covered all of these areas. And I guess we can start. Questions? Alex, I see there. Is there a microphone going on there? Okay.
I would like to start with some comments about your presentation. First of all, I'm a bit surprised that the second speaker looked only at 3GPP vis-a-vis of slicing, when actually the whole world is not only 3GPP. There is more work done at standard groups in ITUT since 2010, much more developed than in slice terms than 3GPP, as well as ETSI, three groups, as well as ITUT and RTF, just to complete the story. And that also proves that the slicing is not anymore one standard group or one groups of open source issues. It's much more than that. The first slides was in 1949 implemented at large, as to my knowledge. So that's interesting to know. Not much, there are no new principles or ideas since then. It's a matter of the fact that now it's becoming to a stage is going to be rewarding in terms of use. So for the stage as I see it, is not what they are and how to create them or destroy them, it's how to use them. Although I'm conscious about around 25 still engineering and research challenges for slicing, as I understand it from a paper which I wrote recently. So it's not a complete story in terms of complete. But we are at the stage, to my knowledge, about how best to use them for different tenants, category of users, as well as operators in order to increase the ecosystem of. And in that context, if I'm right, I would like to ask the panel on two simple questions.
There you go. That's what I was asking.
Thank you. I knew that. What do you believe are the first, let's say, 3 to 5 challenges still to be faced in front of this idea? And more importantly, what is your ultimate vision about this? Is it going to take off? I saw a nice vision in Dirk presentation with movement and having a new way to look at the whole thing. But this sort of thing is needed to drive also the process. So the 2 questions are with you. Thank you.
I think there was a German politician who said, if you have a vision, you should see a doctor. But, right? Please correct.
The other doctor says if you have too many visions and too many doctors, you all have to change.
Okay, so the first question is related with the implementation, and is 3GPP the only standards organization?
No. What are the challenges, which is
the
much
challenge.
more than implementation?
Okay. But
in the
in
view
general,
of the panel,
not in the context of open source and not in the context of open standards. Or?
Whatever context they decide to select.
So,
but the second, it's ultimate vision.
One question at a time. So, who wants to take the first one? Pain points in, let's say, open standards right now. Navid, you want to pick that up?
Actually, I'm not
So
sure.
Let me interpret the question. What are the challenges that you see right now for making, because you had a very nice figure with the car, for example, right? Where it has these 3 slices, and then this was reinforced later with a journey experience from Dirk, right? So what are the impediments, what are the pain points right now to get that thing actually happening from a standards perspective or from an open source perspective or either?
What I could say is that to a large extent, the slicing in the core network is covered by 3GPP. What remains to be remains the challenge is the slicing in the radio access network, and towards that, there is some activities happening in 3GPP. 3GPP in the past brought the idea of the RAN sharing, which we saw in the Dirk's slide. We need isolation. We need a more dynamic resource management. There is also characterizing what is the multiplexing gain and what are the wastes that could come out of that. One, let's say, idea that came out in the scientific research was to introduce this layer, which we call hypervisor or runtime for the radio access network, which means that if you look at the current virtualization technology, they are more for the computing machines. Whereas when you look at the RAN, you want to provide virtualized network inside the system. And to that, you need to, at certain point, at the resource level, radio resource level, you need to provide certain level of abstraction. And I think abstraction is fundamental for the radio access network, fundamental to provide this RAN slicing. And this means that the new resources like radio resources, spectrum resources, they need to be abstracted in a way that these abstracted resources could be provided to these silos we were talking about. So they have either exclusive or partially exclusive or using when available these abstracted resources. When at some point in the level of hypervisor or this runtime, this could be mapped to the actual physical resources.
And that's still not done, basically.
Yes.
Right.
So there are some ideas, few ideas in the research community around that. But of course, you don't want to replicate the cell site as we have today for different operators, right? You want to share the cell site, right? While retaining the control and your resources for your users. So there is an aggregation of the actual cell site. So this means part of the RAN is completely shared, which is close to the antenna and the cell site. And when you come to more radio resources, the behavior, the protocol stack, each operators may customize certain functions like handover, like the way the users are scheduled in the base station, that needs to be customized. So this is where this hypervisor or runtime level could provide certain level of abstraction in terms of radio and spectrum resources, but also in terms of the behavior. So each silo, they could enforce their own behavior, and they could control their own resources, which at the hypervisor level, it will be mapped to the actual resources. So the last thing I want to complete this answer is that in 3GPP, they define this role model, right? So if we imagine this hypervisor layer, what it goes underneath belong to the infrastructure provider, whether they are operators or vendors. What goes on the top of the hypervisors, it is those who are providing the communication and the service. Again, operator or service provider. So there is this role model that changes here. If this layer is introduced in future RAN, the actual, the property of the RAN will be actually decoupled to multiple players. And so the value chain will completely change in that respect.
Okay. Other question from the audience? Yes, Roberto. Here. Yes, but I have 8 minutes, and I need to get more questions. I think you will get your answers at the coffee break then. Roberto, go ahead.
Hello, Roberto Riggio, Fondazione Bruno Kessler, Italy. So they were all very interesting panel. One word I did not hear during the presentations was multi-domain slicing. So I mean, if slicing is going to work in the automotive, industrial, whatever, it's going to be a composition of slices. I mean, let me give you an example. Somebody mentioned that if you drive from one country to another, the car doesn't stop. And actually, I was driving from Italy to Slovenia with a rental car. The car actually worked, didn't stop on the border, but the network did not. So at the crossing between the two countries, voice was out for half a minute, data was out for 1 minute or more. And we are talking about doing slicing without considering how this will work across different domains, different countries, different vendors. So can you comment on this?
I guess that goes to Antje as an operator, perhaps? I guess you will make
it was general
European map purple anyway, so it doesn't matter really. It's going to be one domain, or?
Let me take this partly. I think when it goes to autonomous driving, from my perspective, it's not set yet. How do we technically would provide such thing? You will always have, despite whatever frontiers, barriers between countries, you always will have to deal with coverage issues, right? I mean, in general, you will not have, for the time being, full coverage over every country on every road. So you need to deal with this in general, of course, with the issues coverage. Regarding your question, how do you deal with different operators over frontiers? So we are trialing this out now. I think so. From my perspective, it's technically possible. Yeah. So it can't be that we cannot provide that. For the time being, there is a proposal to do such trial over Germany, Austria, and Italy, actually. To do this from Munich to Bologna, to try out how that works. We might not always have the answer yet, but yes, you're absolutely right. We have to solve this, not only for autonomous driving, I guess.
But Antje, is it primarily, since you have two hats, both engineering and legal, is it primarily an engineering problem, a technology problem, or is it more kind of agreements between operators as you move in, etc.? Is that more of the legacy? We have to pay for, easiness on GSM. So GSM worked fine, but it's still, people exchange documents with CDs, and you know what I mean, right?
Yes. So I guess it's the multitude of different issues. There is legal issues still a lot. Something what is allowed in Slovenia today you cannot do in Germany, actually around driving especially. Everybody is working on a harmonization of those topics, and we will need that to provide service over different countries. I think the general willingness to do that from an operator perspective is there. So I don't think that's the issue.
Another question. I'm surprised nobody said anything about AI yet. Good idea for a panel next year. A blockchain network slice.
In relation to open standards and open source for 5G deployment, to my knowledge, by the mid of the next year, we will have a fully standardized protocol stack, open protocol stack for industrial Internet of Things applications. So where can we expect first results in relation to 5G? What is your prediction?
Who wants to take that? Navid, you want to go ahead, or?
Do you want to take that, please? Difficult question.
Next one.
I'm not sure that will be realized in 5G. Because the things have been decided 2 or 3 years before, what would be the players, the interplay, how things are going to, the agreement has been done before, so it might happen to a certain extent, maybe for 6G, and we know from the fact that every odd number of cellular systems were not successful, so 1G, 3G were not as successful as 2G and 4G, so which makes 5G to be a candidate of not as successful as 6G.
Good news, somebody should tell in the New York Times.
So this is, in our department, we talk about some stories like that. So probably in 6G, some possibility might happen.
Yeah, but by that time, we will have some outcomes from IoT world, so probably to deploy some concept from that. Thank you.
I personally, also as a company, I think we have a completely different opinion about this open source business. So we think that it is going to get much more traction as we go forward for many different reasons. People also tend to be afraid about stuff that they are not familiar with. And in the end of the day, it's lack of familiarity as opposed to real danger out there. People have no problem to download an app, without knowing anything about who made the app, et cetera, and have absolutely no problem to share I don't know how much data, right? And it was surprising how many emails in 5 different languages that I received since I have been using the same email for the last 20 years from random places that I had no idea. And thank God to GDPR, now I know that somebody has my email and other stuff accumulated somewhere. This would have never come to me. But before, unless somebody has a question about the language and the vocabulary, because I think that's something interesting. So do all of us have to, take crash courses on AI and big data and machine learning, Rebecca? So all, whatever, you learn about RAN, then you have to, on top of that layer, whatever this thing is, or are you guys going to start talking, RAN stuff to us back? How is that going to work? How was your experience so far?
So, could you please clarify the question? Do you mean that we need to relearn what AI is?
Exactly. So
right.
Is AI cat picture identification? Do we all have to learn how, cats are recognized by computer machinery, right, these days?
No, not really. I think that we need to review and develop new AI methods that are applicable to highly distributed systems like networks, because machine learning today is very much, like you just said, recognizing cat movies, cat pictures, and handwritten digits, and so on. It's not designed for online it's not designed for aiding short-term, long-term control loops in the way that we need it. So if we're going to have an intelligent network that is able to not only make sophisticated control decisions, but also maybe perhaps be able to reason about certain decisions that has to do with resource efficiency and energy efficiency, then we need to look into how we can design such machine learning methods and AI on top of that, so that it's suitable to this kind of systems that act in very short timescales.
And I see Dirk next to you wants to say something.
Yeah, I just wanted to connect to this and to the previous comment about the odd numbers of Gs. Because there's a lot of skepticism about 5G already appearing in the industry. I mean, if I look at network slicing, I think the fallacy that the industry is running after at the moment is take a method that has been very, very successful in the cloud community and apply it on the network. And they make one very, very, very crucial mistake. The resource waste through slicing. When you go to Amazon Web Services, I'm just doing another VM. I'm doing another one, and I'm doing another one. And it's really wasteful. It's countered on the demand side through throwing more and more compute resources. And why can you do that? Because you have a big, fat, cooled data center sitting somewhere in, I don't know, Dublin or whatever. The problem in a telecom network is you can't do that. Your resources will always be scarce. I remember a network slicing panel at the VTC where the gentleman from Nokia presented all the beautiful methods that have been embedded into 3GPP to actually do even slicing at the lowest level, to finish his presentation to say, but we don't want to use them. Why? It's a scarce resource. Why on earth would you slice your spectrum? I paid 20 billion for it. And you can't slice indefinitely because you can't throw more numbers on it. You can't install, you know, if Google runs out of space and racks, they put more racks in. Are you going to do that at every base station because you figure out that you slice too often? It's not going to work. And that connects to the point that, to Rebecca's presentation, which I really liked, because the observability, which we can do, we can measure much more intelligently and observe much more intelligently than we used to do, which was very crude, needs to be used to tackle the isolation, the waste we're doing with it. Slices need to breathe, and that's also when you get rid of the analogy, because I've never seen a slice that breathes, by the way. If my bread ever breathes back at me, I'm going to freak out. So it's a bad analogy. It is dynamic resource control, and we have to be intelligent, and I hate the buzzword. I don't want to use it because it's banned in my team, so we do not use the buzzword that you just mentioned, right? But we need to get more intelligent and really turn towards using the resources that are and remain scarce more intelligently. And I do believe that's probably looking where the industry is going at the moment, not going to happen before we have 5.9.5 or 6G, unfortunately. And in the meantime, the industry will run after the fallacy that they can slice ad infinitum, and they can't. That's why I believe these numbers I showed will remain very small. You will have one IoT slice, I get that. Right, but you will not have thousands, you will not have millions.
All right. Any last question from the audience? All right, great. I think we have a hard deadline because somebody has to catch a plane. So, and I think we are like 5 minutes over time. So, thank you very much for your attention. These have been our panelists. And let the adventure begin somehow on this network slicing. Thank you very much. I'll please give a hand for our panelists today. They have been really great. And the metric of that was that I didn't see a lot of open laptops writing emails.
Good. Done.
Thank you.
Thank you.
Take care.
Thank you very much, and have a good trip.
Yes. I saw the coherent figures.
Yes,
How can I get access to you?